Hey, how's it going? Today I'm going to talk about a new Alexa buttons game I created called Lie Detector. Alexa buttons are these cool little buttons that you can use to interact with your Alexa. They're running a contest lately that I figured I would try and come up with an idea for. So what was the idea? The idea is a simple game called Lie Detector. Basically, you need at least 2 players and 2 buttons. You can play from 2 to 4 players. Each round, 1 player will be picked to be the counter. All other players will close their eyes. Alexa will then flash the counter's button a yellow random number of times and then ask them to say the number they counted. The counter can choose to say the real number, the truth, or they can choose to say a different number, a lie. Alexa will then ask all the players to open their eyes. Each gives a guess if the counter was telling the truth or lying. If you guess correctly, you get a point, and if you guess incorrectly, the person that was doing the lying or telling the truth earns a point. So basically, I created this app with a framework called Jovo. Jovo lets you build voice applications for both Google Home and Alexa, actually a number of other platforms, but of course the 2 most popular are Alexa and Google Home. It's a really nice framework. It simplifies a lot of stuff, takes care of a lot of things for you. In this example that I'm going to walk you through, I actually didn't take advantage of that much stuff. So you can see the code here. This is actually the entire app that I'm showing you. I only have a handful of intents. So in this example, when I created an Alexa skill, you basically have to define all your details in the Alexa developer console. There's a number of things here, that you need to set: the invocation name, the intents, the building of a model, and the endpoint. Invocation name is just the name of the skill, sort of like what you're going to call it. In this case, it's Lie Detector. Intent, samples, and slots. This is where a lot of the initial setup work goes. This is basically the functions that your app is going to call. And so, for example, here we've got answer intent, end, help intent, launch, on-game engine input handler event, and welcome intent. Now, some of these things are special to Jovo, and some of these things are special to Alexa. So in this case, I have a welcome intent, I have an answer intent, and that's really it. The rest of these are built-in intents that I map to different things inside of my code, and I'll go through that. And then slot types, you can define these to be whatever kind of thing you want your skill to accept. So in my case, I'm using a thing I called it question response. And I'm kind of hacking a little bit of stuff here. So I have basically what you would call a one intent system. And it's going to handle everything that comes in, even though we're going to do different things based on the responses and sort of what's going on. That's not great practice, but I wanted to do this quick and easy, and I didn't feel like doing a bunch of different intents. I actually do this a lot for my Alexa stuff. It's against their best practices list, but I find it to be quick, simple, and especially for little apps and things. So that's intents, and then building a model. So once you define everything in this screen here, you have to build the model so that you can test it and stuff. That's basically just their validation stuff going on the Amazon side. And then endpoint, when you're first working on this with Jovo, you can create a HTTPS endpoint. You can do Jovo run in your command window, and that will give you a URL that you can then put here as your endpoint, and that way you can test all of your stuff local without having to upload it to Amazon as a Lambda. When you're ready for production, you're going to want to go ahead and put it in as a Lambda. There's command line tools with Jovo for things like Jovo deploy. I didn't use that. I just usually zip up the code, and then upload it to the system. So I'm trying to find that for you here. I have a number of other lambdas out here, as you can see. And this code will end up looking the same as the directory that you've seen over here. So basically that's just the production version of the code versus the local version of the code. All right, so the code, let's actually look through the code. For Jovo, basically you can do this intent mapping stuff at the beginning, which is just going to say if it comes in as one intent, you can map it to another intent. So all of the default ones that Amazon sets up for you, I map them, in this case, either to answer intent, which is my generic handler, or to end, to quit the game, or to help intent, which is just pretending someone said help, or if someone said help, it should go to that. So the basic things, and in fact, the help intent is just this, which is basically just creating getting the session, creating the speech builder to simply say the details of the game, and then we're going to bounce around to, depending on what state we were in, how to get them back into the game after help is done. So not a lot really going on there. I'm not going to dig too much into that. And end is also really just closing up the session and saying, thanks for playing. This tell command in Jovo will end the session. So it's a good way to sort of say, thanks or goodbye or whatever. And so you can see most of my mapping stuff goes to either help or end. Answer intent is really the chunk of the game, and I'll dig into that in a minute. But I want to go over a couple of quick other little intents first. So launch is something that happens when Jovo gets this first request from a device. It will by default call launch, and in this case I'm just bouncing it to the welcome intent. So if you say start, or you say if the system didn't map it to the welcome intent already, this is just sort of a double check. We'll grab it and throw it over to the welcome intent. The welcome intent is really where our game starts. And so in this version, I'm basically putting everything into session variables. I have no databases, no external storage of any kind. It's 100% a Lambda and the Amazon Developer Console that we're using to make it simple and easy and quick, and it's not overly complex. So I'm using all session variables. You can use user data, and I'd encourage you to go read the Jovo documentation. They have a lot of things I'm not going to cover, and a lot of things you can do with it. But I like to use session variables. A lot of other people hate them. I use them because I kind of think of it as this one session of the game. We're going to set this data up, and then we're going to throw it out when the session's over. So in this case, I'm just setting a bunch of things up, basically variables up for the session to be available in the session. Not going to use them yet. Not required to set them up here. You can set them up when you're ready to use them. I like to sort of define everything, make sure it's all defined, set there, and then we'll use them throughout the game. And then the first thing the game does is basically, welcomes you to the game and asks you how many players there's going to be. So once you answer, no matter what you answer, hopefully it's a number. If 1, 2, 3, or 4, ideally, since it's a game for 2 to 4 players. If you say something under 2, it should tell you you need at least 2 players. And if you say 2, 3, or 4, it should start to set the setup process. And if you say anything else, it's going to give you some problems. So let's go quickly through this answer intent code. There's a decent amount here, so I know I'm moving fast, but hopefully you catch all this, and you can re-listen as much as you'd like for each little section. So again, I'm just setting up some variables. I do this thing where I don't like having this around my code everywhere. I find it kind of confusing, and it gets a little messy. So different languages require it. Different scope situations require it. I like to just call it state, since that's kind of what I think of it as, is it's the current state. So at the beginning of most of my intents, I do this. I set Jovo state to this, and that's just for my own little quirkiness. You could replace everywhere you see the word Jovo state, you could just replace it with this, and everything should still work if that's your preferred sort of setup. Question response. So whenever an intent gets a value passed into it, Jovo will read it sort of like this, and to get the value that they actually of whatever they said, you can actually just say whatever dot value. So again, we called this this slot was question response. We expect it to come in as question response, and then we're setting the value to question response. And I tend to use underscores rather than camel case. So you probably see that throughout my code. And then again, right here, since we know we set the sessions up, the session variables up in our welcome thing, I just start every instance of the intent by actually getting the values from those session variables and putting them into just, variables that are a little easier for me to use in my code and reference. And then, I'm deriving a couple of values. So how many players do we currently have? I'm just setting up a placeholder for our speech object, and I'm setting a timeout that I'm going to use with button pushing. The maximum timeout is 90,000 milliseconds, I think this is. So I just went with the max for timeouts on each thing. That just helps you give people a little bit longer to push a button, before the thing times out and basically the game ends. And so one of the things I do a lot, if you're going to do a single intent situation, basically you can set a session variable, and then, depending on what that session variable is, you can just determine what section of code to do. Now, if you were going to do multiple intents, you wouldn't need this. You would just do each intent and assume that Amazon's going to bounce you to the right intent with the right thing at the right time. I'm an old enough Alexa developer that it didn't do that well when I first started sort of writing stuff, and so I kind of always got into this habit of keeping track myself in states, in sessions, as to where I want someone to go on the next time that they come through the system. The next time they come through inside of a given app. And so even now that I'm using Jovo, I still kind of like to do that. And that's, again, why I'm just doing a single intent and sort of writing stuff this way. So we have a handful of different sort of intents here we could do. Sorry, I'm trying to... oh, that's interesting. I kind of wanted to collapse that. But basically, we have, button count. We have continue round. We have, flash answer. We have round answer, and continue round. There's a bunch of different states, and it sort of depends on where we are in the gameplay as to what we're going to go to. So we're going to go ahead and walk through some of this, and then hopefully it'll become more obvious. So again, first time through, if you went back down to the welcome section, one of the things we did was actually set our initial listen for button count. So when we get an answer, this is going to be button count. So the very first time through, we're going to be into this section of code. And if they happen to say something that was less than 2, the system's just going to tell them, you need at least 2 players, how many, and it's going to re-ask how many players. If they said something more than 2, we're going to want to go ahead and set the next thing that we're going to come through on the next pass. We want to set the button count to how many players they have, so we know how many we need to be setting up. And now we're going to start doing some of the more interesting button clicking stuff, right? So when you first start a button game, they want you to do a thing called roll call, which is each player is going to push a button, and that's going to send a signal to your Alexa, which is going to give it the device ID and sort of register it with the game. So you basically, to do this, you have to set up a pattern. In our case, we just want them to push the button down. You need to set up a recognizer. And Jovo has great documentation on this stuff too. So I'm not going to go into super detailed things as to how everything is, but I will point out a few things I hit challenges with or had questions about. So a button recognizer basically is just saying, more or less setting it up to say, like, what pattern are we trying to recognize? And this fuzzy false or true is important in terms of, does it have to match that pattern exactly, or can it be kind of like this pattern and still work? So we want it to match this exactly because we're only asking for the down click, and so we don't want it to be fuzzy. And then once you have a pattern and you've set up a recognizer for that pattern, now you have to actually set up an event. And the event basically is, if the thing was recognized, what do we do, right? So in this case, we're going to do, the button down event. And basically when the system meets a button down recognizer, it's going to, perform a button down event. And then the other important thing here is should end input handler. And I kind of messed around with this for quite a bit trying to figure this part out, because in the first register, you kind of want all buttons to be available to be pushed down, and whichever one gets pushed down is the one that you're going to set up. But in the game, when you're going on with players and turns, you like if it's not your turn and you push your button, I don't want the system to do anything. I want it to ignore it. And so the way that works is basically input handlers are sort of saying like which button should we accept stuff from at the time. It's a little bit of part to do with patterns, but you can only have one input handler happening at a time. And so in our case, this pattern that we're at right now, we didn't say which specific buttons you're allowed to use, but so any button will work. The first one you push is going to call it's going to recognize that you pushed it, and it's going to call the button down event. And then I don't want that button to be, I don't want any other button, I don't want the system accepting any other button pushes until we've handled that button push. So that's where should end input handler comes in handy. Basically, it'll accept one button push from any button in this instance, and then it won't accept any more button pushes until we've dealt with that one button push. If this was false, it would accept as many button pushes as we gave it until it timed out or they were all handled. And that was causing me a lot of problems in the first versions. I had this set to false and was just using one recognizer and one event and for the whole game. And it worked, but only if you followed the instructions. If someone was trying to be a pain in the butt and hit the button when they weren't supposed to, it started to cause problems. And it turned out to be a simple just, close your input handlers after every action that you want to wait and figure stuff out for, and then when you go to the next time when you need to accept buttons again, you enable a new one, and you'll see how that happens sort of in the code here. So once you have a pattern and it's recognizable, and then it triggers an event, you have an event that you can trigger. Basically you just have to attach it all together. So that's this set events. So on the button down event, recognize this stuff on a button down event, and then what's the timeout for this input handler. So basically we're now this turns the button on, or whichever buttons you said based on your pattern. And again, in this first instance, any button that you push that's registered with your device will be recognized because you've pushed the down button, and send a button down event, and or trigger a button down event. And the timeout is required just again for so when the system basically says player one press your button, they have until the timeout for somebody to hit a button and start to register it. And if they don't, then basically the game ends. So when we do this, it ends up triggering a button down event, and a button down event is a different method. So this is on game engine input handler event. This is again in the documentation for Jovo. This is how they handle game engine input, and so it's a separate call to the code with the event being triggered. So the button has basically sent its own set of instructions to the code. I go ahead and redo, so again, since it's its own instance of the code, I'll set my session variables up, so all the stuff you've kind of seen before. Here, this is actually code to just go ahead and grab the input event and the name of the event. Now in our case, we're sending it only one event, a button down event, but you could technically allow it to accept different events and throw different events based on different patterns or situations that you've had happen. So it's just good practice to sort of, capture the event name and then, double check that what you're going to perform is what is for the event that you want to perform it. So, if we get a button down event, we want to deal with the button click. So the first time we need to determine if the button is known or not, right? So on every button click, we're actually determining if this is a known button or not. So we get the button ID, which is another value that's just sent with the code or with the response, the signal. And just some quick code here to basically check, is this a known button? We loop through our list of players, which is a session variable that's just an array of player objects that we're going to create. Now the first time through, players is an empty array, and so at this state there are no known players, so known button is going to just be false. So if it's not a known button, we're going to go ahead and attempt to register it. And so we're just going to, add one to our count of players, which, since this was the length of players and there are no players, it's 0. So now the count is 1. We create a player object, and this is just some data about each player we're going to store in the session, in our list of players. And so I give each one a player ID, just the integer, so 1, 2, 3, or 4. The button ID, which is the gadget ID, we're going to use that again for determining whose button should be enabled or disabled. The player name by default is, player 1, 2, 3, or 4. And then the request ID, I don't actually use this in the code, but this is something, and the Jovo documentation also talks about this, but this is something you can use to sort of determine that the button clicked, it will have the same request ID as a response will when they're supposed to be tied together. And so you can sort of check that for trivia games and other things to sort of say, like, is the right person hitting the thing, is it tied to the right request? Because, it's saying something is one request, pushing a button is another request, and these things happen at different times, potentially. So even though they're supposed to be tied together. So request ID, you can check it against being the same or not and see what happens. I don't use it, but I did store it in here just to keep it. And then points, we're going to use that to keep a running total of who scored what with our game. So now that we've changed some values around, I want to put them back into the session. So I just, make sure I save them to the session. And then we're going to go ahead and ask, so the first person has hit a button. Now we're going to say, great, we got your button set up. What name would you like to play with this? What name would you like to use for the game? And, you've noticed we've set listen for to setup. So the next time somebody says something to the system, we're going to be back in the answer situation, and we're going to go look for listen for setup. So we're going to go down to listen for setup. Alrighty. And so here we are, listen for setup. And basically, we're going to go through and find which button the person pushed that we want to associate this name to. We're going to set, we're going to go ahead and update their name to question response, which in this case is whatever name they said. So Kevin or the Dominator or Mr. Lie Detector, whatever you want. It should be set. It'll be put in here. It'll be saved. And then just to make the game a little more interesting and fun, I do a little bit of code here that randomly will pick sometimes it will go ahead and say something about the name you picked. So about 25% of the time it will pick something. It'll pick right now from this hard-coded list. So it'll say, so for example, if I said, my name is Kevin, it would say something like, Kevin, that's a funny choice, but okay. It's just supposed to add some fun to the game. So if you play the game, occasionally you should hit that, and it should hopefully be funny and interesting and keep the game a little fresh. And then basically, so now that person's registered, we just have to check, like, do we think all the buttons are registered, or do we need to add another have another person register? So, this goes back to what we originally said when you started the game, how many buttons are going to play with. If you said 2, and this is the second button that was just set up, then we're ready to start the game. And if not, then we're going to go ahead and just ask the next player, push your button, and then we're going to go back through that whole loop and say, what do you want to call yourself? Okay, great. Once we're ready, we're going to start the game. So now we're going to go ahead and set a session variable that we're in the game. We're going to randomly pick one of the players to be the first person that counts. We're going to make sure we save all of our stuff back into the session, and we're going to be looking for lie instructions on the next time we come through. So now we start to give the instructions, which is close your eyes, and then whoever's current turn it is, we're going to go ahead and say, you open your eyes, look around and make sure everybody else's eyes are closed. If they are, push the button. And in this case, the big change so now we're going to enable their button. And what we wanted to do is what we added to the pattern here is this gadget ID that's going to say, if it's player one's turn, then only player one's button is the only one we're looking for the down action on. So anyone else can hit their button and it's going to do nothing. It's not going to, the system's not even going to get the alert about it because it's not looking for those patterns. So, now we go ahead and call the, the same basic stuff in terms of recognizer, event, and, associating them together. And we prep the system to wait for that button down event. And so now when the button down event occurs, again, we had it set for lie instruction. So we're going to go ahead and close up this part of the code. Go back to button down event on game engine input handler event. And we're going to look for lie instructions, right? So they're all known buttons. We are in game, so we then check if the active button is the button that was actually pushed. This was actually, it's not needed in this version. This was, I had this in here when I was using the one handler that handled all button clicks. So it is, I kept it because it doesn't hurt, but it basically should never be true with our current code. But if it was, it would basically ignore the fact that the wrong person pushed the button. So now we should be down to this if statement, and in fact we are looking for lie instructions. So we're going to go ahead and basically tell the current player whose eyes are open what they're supposed to be doing, which is, we're going to tell them quickly about the game and tell them that we're about to flash their button yellow a number of times, and they can choose to tell the truth or lie about how many times we flash it. And so then we just tell them, go ahead and push your button, when you're ready for us to start the flashing. Again, the big thing here is gadget ID. It's the current person's button that we're keeping enabled, basically. So because we turn that enable, or should end inputs to true, is when we got to here, the input is, even though it was the same button, we haven't changed the button or anything. That one button down press, ended the input handler. So we have to re-enable a new input handler, again for the same player, but basically saying, okay, when you're ready, push your button, and we'll start flash. And so we've set listen for start flash. So then when they push their button, we're basically going to come back to this button push event, and instead of lie instructions, we're going to look for start flash. And so start flash is right here. And basically, we know that after we flash it, we're going to be listening for flash answer. We're going to basically pick how many times we want to. We're going to randomly assign how many times we're going to flash the button. Right now, it's basically 1 to 4 times because I don't want the flashing to take forever and make people have to count forever. We're going to build up a sequence of flashing. So basically, when you create an animation, you basically do a sequence. So in this case, we're basically making it, yellow for a certain yellow and then white, yellow and then white, and we're going to do these in sets of 2 each time, so that basically the button will go turn yellow and then turn white and then turn yellow and then turn off. Basically, sorry, it's yellow and black. But black means the button's basically off. We're going to do that flash count times, so either 1, 2, 3, or 4 times it's going to flash yellow, and then at the end we flash it to a red, and so that it's done. And in the instructions we tell them, when you see the red light, please say the number of yellow flashes you counted, which is what we end up asking at the end. Now, gadget controller is how you actually set those animations and turn them on. And basically, the sequence we built up is the sequence we pass in, and for what button, and there's some other options and things you can play with here. For this game, it was basically just flash the person's button, those colors, and then ask them how many flashes. So now it's waiting for them to give an answer. We're gonna go back for flash answer, and flash answer is a spoken thing, so that's going to be back in answer intent. We're going to come back to flash answer. We're going to go here. Basically, the code ended up getting here. The flash answer is going to be hopefully a number that they said. We're going to go ahead and set the flash answer to whatever the person said, just a session setting. We're going to determine if the person actually told the truth or not. And we do that because we kept track of how many times we were flashing it. We put that into a session variable, and we now know what number the person said. And so we're going to assume they're telling the truth, and then we're going to find out if they weren't, then it was a lie. And we just basically set a session variable to store whether they were telling the truth or whether they lied. And so now we're going to give instructions to everybody else, which is everybody should now open their eyes. We're going to ask each person, if the person counting was telling the truth or not. And we want to basically start from, depending on how many players you have, if you have player 1, player 2, and player 3, and it was player 2 that was doing the lying or telling the truth, we want to start by asking player 3 and then go to player 1. So it's sort of looping around the list. That's just sort of what this code here does. And then basically we make sure we know who we're waiting to get an answer from, whose button we should activate, and when the next request we want to do a round answer. And so then we tell the person that we want an answer from to push their button. And again, it's gadget ID settings, so just activating that one person's button. And so basically when we come back, we're going to go into a button push event for round answer. So a button push an event, go down to find round answer, so lie instruction. So round answer is here. Basically, we want to make sure we set the active button to what we currently have. And we're basically going to ask that person, okay, do you think that did they say truth or lie? And depending on what they say, they're going to come back to a voice version of round answer, right? Which is here. So the voice version of round answer is, again, we're going to assume that the person thinks they're telling the truth, and then detect with a simple check for the word lie or lying. And if they say either one of those words in any of their response, then we're going to set it to assume they meant lie. Now we're going to determine if that person actually correctly guessed or not. So, if I was telling the truth and you said I was lying, then you were wrong. If I was telling the truth and you said if I was telling the truth and you said I was telling the truth, then you're right and you should get a point. So basically, if your answer matches what it's supposed to, you're going to get a point. So the guess is going to be set as correct, and you're going to be awaiting. You're going to get an extra point. And I store the answers in sort of a session variable as well, so that I can keep track, as we go player by player, how many answers have we collected, what are those answers. So, and again, I just for fun, I added in a thing where, about 10% of the time, it will make some sort of comment on the answer that you gave. So, like, I think Kevin's telling the truth, and, it'll be like, oh, of course, Marshall, you think that, Marshall, of course you think that. Or, ha, figures. Again, that's just to add a little bit of fun, hopefully. So then we've gotten the person's answer. We have to determine, like, if everyone's answered and we're ready to move on, or if we haven't, we have to, go ahead and move to the next person, get their answer, enable their button and get their answer. And if after we've done that for everyone, we're going to go ahead and award the points and give the details, and then basically ask if they want to go to the next round or not. So, correct and incorrect, we're just kind of keeping track of how many correct and incorrects there were. Remember, we were putting all this stuff into a session variable that was the answers, so we can simply just loop through that and collect how many were correct, how many were incorrect. For every incorrect answer, the person that was the counter earns a point, so they're getting a point there. And then basically, one last time, we basically determine what, if they were telling the truth or lied. We just want to format that for revealing to everyone. So we say, okay, great. Turns out Kevin was telling the truth. And so now we're going to go through and tell everyone the scores based on the current situation. So first round, Kevin's got 1 point, Marshall's got 0 points. And then it basically says, would you like to play another round? And it, sets the attribute to continue round, and it'll ask that question. So when you come to continue round, it will basically come back here, and if, again, just checking for the word no, otherwise it's going to continue the round. It's going to determine who's the next one up. It's going to randomly pick, but it's going to randomly pick, making sure that the person that was just the counter is not the counter again. And then basically we're going to start the whole process that we just went through over again, setting the current players button active and asking them to start, and re-looping through. And if you had said no, we don't want to continue the game, it's gonna bounce you to the end intent, and the end intent again just says thanks for playing and ends the game. So I know that was a whirlwind of stuff, but that's basically the details of the app. That's the full code walkthrough. It's available on GitHub, on my GitHub account. It should be linked to from this if you want to check it out. It's publicly available. The app at the moment is submitted for review with Amazon. It's not actually approved at the moment, so hopefully it'll be approved in the next few days, and I'll put it out there. If it gets rejected for some reason, I'll make the fixes and sort of update this to let you know. But basically, that's the gist of it. Hopefully you like it. Play around with it. Check out the buttons. Do something cool with them yourself. Use this as a basis if you'd like. And, hit me up with any questions or comments. Thanks. Talk to you later.